Hi guys, in this video we are going to discuss an interesting question from bulk modulus of the liquid. If you haven't subscribed our channel yet, please do it fast. Also, we have done many videos regarding fluid mechanics as well as basic fundamentals of engineering. If you like to watch them, please, I have given the link in the description. You can always use that. Okay, without wasting your time, let's move to the question. So in this question, they are asking the bulk modulus by giving some data. As you can see over here, there is a liquid with a volume of 0.1 meter cube at 150 kilopascal is subjected to a pressure of 2000 kilopascal. This volume get decreased by 0.2. So we need to find the bulk modulus of this liquid. So when you are considering about the bulk modulus, actually you need to know what's the equation for that. What's that? So when you are considering about this bulk modulus, using this bulk modulus, you can measure the compressibility of a liquid or gas. It can be. It's basically for fluids. When you are considering about the bulk modulus, you are going to describe that liquids or that fluids compressibility. If this bulk modulus is high, you can tell that there's going to be the low compressibility. Likewise, you can tell that, you can describe that compressibility using this bulk modulus. So we are going to find that first. So when you are considering about that, what's the equation for that? You need to know that, otherwise it would be very much difficult for you. Actually, that is, it's going to be minus V into dP over dV. Or in other terms, we can relate, this is volume and pressure. You can change this volume to rho also, the density also. You can, if you use that, you are going to get rho into dP over d rho. Some might wonder why there is no minus over here. The reason is, when you are giving the pressure, let's say when you are giving the pressure, automatically the volume is going to decrease. So we can't get the bulk modulus is in the positive value. It's going to have the positive value, so that we are going to have this minus, and it will change that minus into plus, positive. Likewise, when you are considering about the rho, it won't be decreasing, it's going to increase with the pressure. When you increase the density change, the pressure is also going to increase, which means when you increase the pressure, only the density is going to increase, so it's going to be positive, no problem over here. When you are considering about the volume, when you are giving excess pressure on a balloon, let's say there is a balloon with a gas, when you are giving excess pressure on it, the volume is going to decrease, which means it's going to be minus. So that if you get this minus sign, it's going to make the whole thing into plus. So these are the equation. However, they have given all the things in the volume, so we are going to use this one. And another one more thing is, you can directly tell what's meant by the compressibility, or whether it's going to have high compressibility or low compressibility using this bulk modulus value. Let's say this bulk modulus, the K value is higher for a liquid or for a fluid. You can tell that dP over dV is going to higher. What's meant by the dP over dV? To make change of, let's say this is 1 meter cube. To make a change of 1 meter cube volume, you are going to give a certain pressure, that's known as dP over dV. To make a change of a fluid by 1 meter cube, you are going to give a pressure, so that's known as dP over dV. When we are having a higher K, which means higher bulk modulus, you need to give the dP over dV is going to higher for the same volume of fluid. So from that we can tell if dP over dV is higher for a certain volume. If we are going to increase or decrease that volume by 1 meter cube, we need to give the pressure high pressure. So which means it's going to be a low compressibility, which means you can't, it's very difficult to compress that fluid, so it's going to be low compressibility fluid. So that's known as, you can describe the compressibility of fluid using this bulk modulus. That's the main thing. Okay, that's the point, I should figure it out. Okay, let's move to this question. So when we are considering about this, there's a liquid of 0.1 meter cube. Actually, we knew the volume right now, it's going to be 0.1. At 150 kilopascal is subject to a pressure of 2000 kilopascal. What's meant by the delta P? dP is, we need to find the change between initial pressure and final pressure. So what's going to be the change? Actually, you can figure it out over here. We are going to change from 150 kilopascal to 2000 kilopascal. Likewise, so now we have figured out that, so what would be the dp, the change in pressure, is going to be 2000 minus 150 kilopascal. So we have now figured it out. So after that we need to find the delta v dv. So how we are going to find that? Actually it's going to decrease by 0.2. so there are many methods, but I'm going to show the very big method, and after that I'm going to show the shortcut. So when you are considering about the delta v, actually we knew the initial volume, which is 0.1 meter cube, but however actually we don't know what's the value of the final pressure. If we know the final pressure only, we can find the delta v. How we are going to find this? Actually we knew that this is going to be 0.1, it's going to decrease by its 0.2 percentage, which means the final pressure, sorry, final volume would be 0.1 into its 0.9, sorry, it's going to be 99.8%. Actually it's going to decrease by 0.2, means it's having 99.8% balance. So let's use this calculator for that. So 0.1 into it's going to be 99.8. So I'm going to percentage 998. It's going to be 0.0998 meter cube. Now figure it out. We have figured out those values. So the next step is we are going to use the equation and figure it out. So remember, when you are considering about the delta, let's just substitute of the value first. So when you are considering the v, it's going to be 0.1 in the initial, so you need to mark by the initial volume, and the delta p is going to be 2000 minus 150 final minus initial. It's going to be 1950 kilopascal, so you need to put the 10 cube over here. And the next thing is delta v final minus initial. When you are considering about the delta, the change in any quantities, you need to consider the final quantity minus initial quantity. So 0.0998 minus 0.1, you are going to get the answer in minus, and it's going to be 0.0012302. I think this one. Okay, so we need to solve this one. If you solve that, you are going to get any answer. This is the minus is going to be cancelled out. So when you are considering about this, it's going to be 10 cube, so you can directly write it like this. It's going to be 100 950, and here over here you can tell it's going to be 2 into 1 2 3 4 10 to the power minus 4. So we need to solve these ones and get the answer. Oh, it's a little bit very big one, big answer. We are going to get a very big answer. I think 10 to the power 4 in 10 to the power 6, if you get the powers of 10, it's going to be 10 to the power 6, and if you divide that, you are going to get 925 10 to the power 6, which we can write it like this, meca and pascal. Okay, that would be the answer. Hopefully you have understood this. First of all, we are finding the dp, and after that we are going to find the delta v using, they have given that it's going to decrease by 0.2. we can actually get that it's when it's decreasing by 0.2, we can directly take that the final, the balance part is going to be 99.8% of that initial volume. So what's the shortcut method over here? Actually you can directly use that shortcut method over here. What's mean by the 0.2 percentage? Actually you know how we get this 0.2 percentage. You can easily figure it out the shortest method. When you are considering about this, let's say, I'm writing like this here. So when you are considering about the 0.2 percentage, what's mean by that? Actually we knew that the percentage, the decrease percentage would be delta v over v naught into 100. It's the percentage over here. It's the 0.2 percentage. So over here you can tell that we are going to have, what's mean by the 0.2 is delta v over v naught into 100, which is equal to 0.2. So that's the main thing. If you know that, you can directly substitute and get the answer first. So actually we don't need to find the delta v separately, because in this equation we are going to have delta v. If you bring this v over down, you are going to get delta v divided by v naught, which is the initial volume. So that actually it's enough. If we find the percentage of this delta V over V naught only, it's going to be delta V over V naught, which would be equal to 0.2 into 10 to the power, 10 to the power minus 2. In other terms, we can tell 10 to the power minus 3, 2 into 10 to the power minus 3. So we can directly substitute over here, but forget about the minus sign over here because it's going to be minus. We are going to neglect that. So the K would be dP over dP over dV. In other terms, we can write it like this: dP over dV over V. Actually, we have this one dV over V over here, so you can directly substitute over here. It's going to be 2 into 10 to the power minus 3, and the change in pressure would be 1950 into 10 to the power minus 10 to the power cube, because it's a kilopascal. You are going to get the same answer very easily if you are using what's meant by this 0.2%. But the change in the volume if you use this part directly. Hope this video would be useful for you. If you have any doubts, please comment it below, and please don't forget to subscribe. Thank you for watching.